In this case, you're asked for the total area enclosed between two different graphs. And on this year's AP test, it's hard to kind of think through how this might be asked because we're going to be allowed to use our calculator, and using it can make it quite a bit easier. But they could give one where you just have to show your work and do it all by hand, I suppose. I just don't know. But I think the important things to realize are that, of course, first we have to draw each function. And area can only be positive. So if you are asked for total area, then even though in this case one of the curves is on top, and on the right-hand side the upper curve changes, both of these areas are by definition positive. And so a key error might be to just find the intersections here and here. We'll find them here. Go ahead and find them on your calculator. You should have found negative 2.571, negative 0.143, and positive 2.714. If you were just to do the integral from negative 2.571 over to 2.714 of the upper curve minus the lower curve, the upper curve would start out to be x cubed minus 4x. You'd get the totally wrong answer. The answer I got was negative 5.308. But the reason this is wrong is because it's treating the first portion as positive and the next area as negative, because the upper and lower curves switch. Instead, since we can use our calculator, if we looked at the absolute value of that same integral, that would result in the correct answer. A much higher number of 24.696. If you didn't have a calculator or you had to show this by hand, then you would be forced to set up two different integrals. The integral from negative 2.571 to this intermediate intersection of negative 0.143. And in that case, we would have x cubed minus 4x minus 3x plus 1. And we would set up a second integral from negative 0.143 to the upper limit of 2.714. But in this case, the line is now the upper curve, and so 3x plus 1 would come first, and we would subtract, in parentheses, x cubed minus 4x for the second graph. If we had to do this by hand, these two graphs would be simpler, and we could find where they cross algebraically. Then we would be forced to set up two integrals. So I wanted to review that as we were doing this problem.